We are going to talk about how to solve exponentials and logarithms now. You are still going to need your calculators out. You should have had them out for the warm-up, so just keep those out. First, just a reminder, this was something that you kind of did a little bit with on that worksheet that you got after the quiz, being able to convert between logarithmic and exponential form. So logarithmic form, you're going to have the word log. It's that log function. You're always going to have log. And then there'll be a number that as the base that you write very tiny down in the corner. It's kind of like a reverse exponent, a subscript. So make sure it's smaller and down. And then you're taking the log base b of something. Actually, I'll use a because that's what I used before. Of something, of an expression, of a number. There's going to be something that you're taking the log of. And then it's going to equal something else. Again, it could be an expression, it could be a number, something. Okay, so that's log form. To go to exponential form, the base of the log is still going to be the base of your exponent. So you always start with the base. And you go across the equal sign. Whatever this equals is going to be the exponent of your exponential. And then you come back around and it's going to equal whatever you were taking the log of. Okay, so there will be questions on the test where all you have to do is convert. There was questions on the warm-up yesterday where all you had to do was convert. Some of you still wanted to try to solve it, but if all you have to do is rewrite in exponential form or rewrite in log form, this is all you have to do. You're just rewriting, no solving. This is when you're rewriting or convert. There's no solving. Yeah, we're going to use this to solve, but if all I'm asking you to do is rewrite or convert, you just got to go in between the two forms. So to use this ability that we have to convert and rewrite logs and exponentials in the other form, we can use this to help us solve exponentials and logs. And it is most helpful to use when the x or when what we're solving for is on the inside. So when here, like the x is what we're taking the log of, or here in the x is in the exponent. When we have those situations, then converting is going to be helpful, because if we just look at our problem that we have initially, there's nothing we can do to solve that because the x is inside that log. But if we convert letter A here, if we convert this to exponential form, the base of the log is the base of your exponent. You go across the equal sign to get the number that's in the exponent, and then you come back around and it equals x. Now x is by itself. What is 3 squared? 9. So the answer is 9. Okay, and then letter B, we can do the same thing. The base of the log is the base of your exponential. Go across the equal sign to get your exponent. Come back around for what it equals. You can type this in your calculator. Make sure you use parentheses. So you would type in parenthesis 1 divided by 2, close the parenthesis, caret, and then 4 in parentheses. And you're going to get a decimal, but if you hit math enter enter, it will turn it back into a fraction for you, and you should get 1/16. Okay, do you guys have any questions there? So in this case, once you convert this log to exponential form, the x is by itself, and we know how to evaluate exponents. Our calculator can do that. Yes. Okay, now with letter C, we have an exponential here, but x isn't by itself, so we can't evaluate it as is like we could for a and b. So we can try converting it into log form. So the base of our exponential, this 3, becomes the base of our log. And then the exponent always goes after the equal sign. They both start with e. Exponent goes after the equal sign. And then whatever our exponential equaled, that's what we're taking the log of. Okay, so here now x is by itself, which is good when we're trying to solve for a variable. Getting that variable by itself is step 1. However, in our calculator, we do not have a log base 3 button. Remember, the only logs you can type into your calculator are log base 10, the common log, or natural log. So we're going to talk about how to evaluate this in a second, but right now this is a very good step 1 because x is by itself. That's good. We'll figure out how to plug that in the calculator in a second. Right now we're just converting. Okay, and letter D, same thing. This x is in the exponent. We can't solve it right now. Sometimes if you look at it, you could be able, like if this was 4 to the x equals 16, 4 squared is 16, so you could figure out that x has to equal 2. But here there's no obvious answer for what x should be. X is not by itself, so we can try converting this into log form. So the base of your exponential becomes the base of your log. Yep, whatever the exponential equals is what you're taking the log of. And then the exponent goes after the equal sign. Okay, so now x is by itself, which is good. We just got to figure out how to evaluate logs of a base other than 10. All right, any questions on the converting part, going from exponential to log form and back? Okay. So now, again, remembering what you guys did on that worksheet after the quiz here, remember how we evaluate logarithms. Whatever the base is the number that you're multiplying, number that you multiply by itself. Then whatever you're taking the log of is what the answer should be. And so here we're trying to figure out what's the exponent, or how many, I don't know, stop talking please. Or we're trying to figure out how many 2's do we have to multiply together to get 8. So if we do 2 times 2, that gives us 4, not 8 yet, but if we multiply by another 2, that equals 8. So since we multiplied 3 2's, our answer is 3. Because 2 to the third power equals 8. 2 times 2 times 2, 3 2's together, we get 8. Now, this is good when the answer is actually a multiple of the base. Like we could do 2 times 2 times 2, that equals 8. But it's not always going to work out where you'll have a number raised to a nice integer exponent. And so we have a way to use our calculator to help us, even though we can't directly plug in logs of different bases into the calculator. There's what's called the change of base formula, where basically mathematicians are like, fine, calculators don't want to do it. We don't know how to do it with the calculator, so we are going to just change up the formula so that we can use our calculators. So when you have a log, base b of something, we can rewrite this as log of the answer, the common log, so that's log base 10, over log of the base. The base always goes on the bottom. Base is on the bottom. And now we have the button, the log button on our calculator. We can now evaluate logs with these different bases. So for example 2, like here, x is by itself already, which is good. That means we don't have to do any converting. We don't have to rewrite anything. We can just use our change of base formula to plug that into the calculator. So 2 is our base. 10 is the answer. So we'd have log of the answer divided by log of the base. Now when you plug this in your calculator, parentheses are very important, and you got to remember that there's 2 logs. It's not log of 10 over 2. It's log of 10 divided by log of 2. So when you plug it in the calculator, you would hit your log button. It would pop up with a parenthesis. You would type your 10. Then you need to close the parenthesis. It's very important that you close it. If you don't close the parenthesis, you're going to get the wrong answer. And then you hit divided by. Then you'd hit log again. Pops up with the parenthesis. And then you type in your 2 or your base. Okay, so go ahead, practice plugging that in your calculator. Again, you're just using the LOG key.
So then it's going to be a decimal?
Yeah, these are going to be decimals, yep. So you should get x equals 3.32. Rounding to 2 decimal places is a good rule of thumb here. Okay, can you guys try B and C? So use the change of base formula to plug it in. The log of the answer divided by the log of the base. Make sure you're closing your parentheses. So for letter B, you should have typed in log of 4 with that closed parenthesis there, divided by log of 1 divided by 2, 1/2, or you could have done 0.5. It's the same thing. And when you plug that in, what did you get? -2. Good there? Don't put the phone down, please. Thank you. Okay, then letter C. Should have had log of 3 with that closed parenthesis there, divided by log of 5. And what did you get for that one? 0.68. All right. So if you have x by itself and it's equaling some log that's not a common log, that's not base 10, then all you got to do is use the change of base formula to plug it in the calculator. You don't have to do any other rearranging. All right, questions? Okay. So now there is something in addition to the exponential or logarithmic form. If it looks different, you have to first move it before converting, meaning you have to either solve for the log or solve for the exponential before you can convert anything or before you can do the change of base. So like here, our exponential is the thing that's being raised to the exponent. So in this case, 3 to the x. This is our exponential. Our exponential is not alone on this side of the equal sign. There is this 2 being multiplied. So before we can do any converting or do anything of that sort, we have to get rid of that 2. How would I get rid of that 2? Divide. Yeah, it's being multiplied, so you would divide both sides by 2. So then we'd have 3 to the x power equals 6. Now the exponential is by itself, and so now we can try our tricks here. So do we know 3 to some power equals 6? Do we know any exponent that x could be that it would get a 6? No, because 3 to the first is 3, 3 to the second is 9. We missed 6. Okay, so that means now we can try converting. So we have it in exponential form. We're going to try to convert it to log form, see if that will help us. So the base of our exponential becomes the base of our log. So we log base 3 of 6 equals x. Okay, now x is by itself, which is good. That means we don't need to do any more rearranging. We just got to figure out how to evaluate that other side of the equal sign. We have log base 3 of 6, so it's not a base 10, so that means we can't plug it straight into the calculator, but we can use our change of base formula and then plug that in. So we can have log of 6 divided by log of 3. We can use change of base. Okay, so go ahead and plug that in. Log of 6, close the parenthesis, divided by log of 3. You should get 1.63. Yeah? Cool. Okay, can you guys try letter B? Sorry. Can you guys try letter B? So remember, you need to get the exponential by itself first, and then you can try converting. So letter B, the exponential is the 5 to the x power, but it's not by itself yet. You should have subtracted 4 from each side so that we can get that exponential by itself. So you'll have 5 to the x equals 24. And now, whenever you're at a point when you're solving and you're looking at something and you're like, well, there's not much I can do there. I don't know an exponent that we could raise 5 to get 24. X is not by itself. Then at that point, once you're stuck and you don't know what to do, converting is a good next step. So we can try converting this into log form. So we'll have log, what would be the base of my log? 5. What would I be taking the log of? What goes in the parentheses here? 24, which means it will equal x. Okay, now x is by itself. Yay. How would I get a number for x? What could I use? Yeah.
I was going to say divide.
There is some division involved in what we're going to do. If I have a log that's not base 10, what do I do to be able to put it in the calculator? Yeah, Angelina?
Log 24.
Yeah, use the change of base. So you'd have log of 24, close the parenthesis, divided by log of 5. And what does that equal? 1.97, thank you. Okay, are we good there? So converting and change of base are the two things you got to remember how to do. Converting between log and exponential form and using the change of base formula.
2 for now, because
If there's a decimal, put at least 1 or 2 decimal places, yeah. All right, letter C. So this is the same idea, just like how we had to get the exponential by itself before we could do anything. We have to get the log by itself before we can do anything. So this log base 2 of x, we need to get that by itself. How would I get that by itself? Well, what's happening with this 2 here?
add 2.
Yep, you would add 2 to both sides. So we'd have log base 2 of x equals 6. Okay, now looking at the log as is, do we know what x is? Can we figure it out just by looking at it? No. Is x by itself? No, so that means we can try converting. So the base of my log becomes the base of my exponential. We go across the equal sign to get our exponent, and we come back around to get what it equals. So now x is by itself. Yay. So that means we can use our calculator to evaluate 2 to the 6th power. So you would do 2 caret 6 in parentheses. And what do you get? 64 equals x. Yes. I zoom in. All right, letter D. Now we have a couple things that are preventing that log base 4 of x to be by itself. So, what?
Subtract 1.
Yes, yeah, so we have log base 4 of x we want to get by itself. Remember, when you're solving for something, you do the order of operations in reverse. So you deal with any addition or subtraction first. So yes, we would subtract 1 from both sides. And then, to get that log by itself, we can divide by 2. So we'd have log base 4 of x equals 3. Now, looking at it, we don't know what x is right off the bat. X is not by itself, which means we should try converting. So the base of my log is the base of my exponential. Go across the equal sign to get the exponent. Come back across to get what it equals. Okay, so now x is by itself, and we can plug an exponential into our calculator. You can do the 4 caret 3. And what is 4 to the third power? 64. Okay. Okay, do you guys have any questions? Darnell, any questions? Maybe a more specific question? Okay, we'll just do some more examples. How about? So some helpful things to try when you are solving. Since the problems can be set up differently and the x can be in multiple different places, there's not one set process that you need to follow. You kind of just need to try stuff and see what works. So the first thing you want to do is just look at the problem. Sometimes you can figure out what the answer is just by looking at it. After every time you do something, once you convert, look at it, see if you can figure it out. Once you move something around, look at it, see if you can figure it out. So after every step, look to see if the answer is in front of you. Especially if x is already by itself. If your variable is already alone, then there's probably not much more you have to do. Not right now, Darnell. So especially if x is already by itself, then chances are you're almost done. You just have to type something in the calculator. So don't do more work than you have to. If you just keep converting back and forth between log and exponential, something's wrong. Okay, so if you're looking at it and you still can't see an answer, you still don't know what you should do, then the second thing you can try is converting, going in between log and exponential form. Okay, so you can go between log and exponential form. Base b of a.
No.
A little arrow, just saying going in between log and exponential. Okay, so try converting. And then once you convert, take a look at it again, see if you can figure out the answer, especially if your variable is already by itself. If you still can't figure out what the answer is right off the bat, and it's in log form, then use your change of base. Okay, so if your equation is in log form and x is by itself, then you can use change of base. Okay, so always the very first thing you should do is make sure that the exponential or the log is by itself. So do those reverse operations to solve. Gentlemen, please. Use those reverse operations to get the exponential or to get the log by itself. Then go through these things. Just look at it, see if the answer appears. If that's not working, try converting. And if that's not working and it's in log form, try change of base. So again, there's not really one order that will work every time. You just kind of have to go through the motions and see what works. Okay, so let's do another example. So example 4, again, we want to solve the following for x. Is our log by itself right now? No, so we need to get that by itself. So what should I do first? Add 7. So we'd have 9 equals 3 log base 5 of x. Is my log by itself now? No. Nope, so what should I do? I got to get the log by itself first. How do I get the log by itself? Divide by 3. Because this is multiplication. You're not stupid. So you have 3 equals log base 5 of x. Now we can convert, because now the log is by itself. And looking at it, we can't really figure out what x is off the top of our head, so we can try converting. Base of our log is the base of our exponential. Go across the equal sign to get your exponent. Come back around to get what it equals. If you want to rewrite it, flip it so it's log base 5 of x equals 3, just so it's in that familiar format, that's fine. But the converting still works the same way. And then you can use your calculator, 5 caret 3, and what do you get? 125. Okay, any questions there? Okay, letter B. 3 to the x is my exponential. It's not by itself right now. What should I do first to get it by itself? Subtract 3 from both sides. Okay, it's still not by itself. What should I do next?
Do the thing where you put the 4 in front of the other thing, right?
Well, not yet, because the exponential still isn't by itself, so we still have to solve. Divide by 2, yep. Now, looking at it, do we know what x could equal right off the bat? No, so what should we try? Converting. Should have log base 3 of 2 equals x. Okay, now x is by itself. That's really good. That means we're almost there. How can I plug log base 3 of 2 into my calculator?
Log 3 divided by log 2.
Flip it, but yes. Yeah, the base is always on the bottom. So you'd have log of 2 divided by log of 3 in your calculator using change of base. Make sure you close the parenthesis after the 2 there. And what do we get x to equal? 0.63? We'll do 0.63. Okay. All right. Any questions? All right, can you guys go ahead and do the self-assessment? I'll check it, give you the homework.